Hi everybody, I am Shenbagavallì, Assistant Professor of Dept.of Electronics, GVN College, Kovilpatti. I am going to share about 8085 microprocessor addressing modes. What is addressing mode? It performs any operations. We have to give the corresponding instructions to the microprocessor. In each instruction, programmer have to specify three things: operation to be performed, that is opcode, and address of source of data, that is operands, and address of destination of result. And in any microprocessor instructions, the source and destination operands can be a register, memory location, 8-bit number. The method by which the address of source of data and the address of the destination of the result is given in the instructions are called the addressing modes. 8085 uses the following addressing modes. There are 5 addressing modes. What are they? Direct addressing mode, immediate addressing mode, register addressing mode, register indirect addressing mode, implied or implicit addressing modes. First, we are going to see about direct addressing mode. The data to be operated is available inside a memory location, and that memory location is directly specified as an operand. Here, the operand is directly available in the instruction itself. For example, LDA 2100, that is, load the contents of memory location into accumulator A. And the next example is LHLD address, that is, load contents of 16-bit memory location into HL register pair. And the next one is immediate addressing mode. In this mode, the operand is specified within the instruction itself. That is, the data is 8-bit, then the instruction will be of 2 bytes. The first byte is opcode followed by an 8-bit data. If the data is of 16-bit, then the instruction will be of 3 bytes. The first byte is opcode at memory location n, followed by the higher order data byte at memory location n plus 2. For example, MVI B45, that is 45. That means move the data 45H immediately to register B. And the next example is LXI H 4200. It means load the HL pair with the operand 4200H immediately. And the last example is JMP address, that is, jump to the operand address immediately. These are the examples of immediate addressing modes. And the next one is register addressing mode. In this mode, the operand is in general purpose register. The data to be operated is available inside the registers, and the registers is operands. Therefore, the operation is performed within the various registers of the microprocessor. For this, the examples are MOV A, B. Move the content of register B to register A. ADD, add B, that is, add content of register A and B and store the result in register A, that is, in accumulator. INR, increment the content of register A by 1. And the next one is register indirect addressing mode. In this mode, the address of operand is specified by a register pair. The data to be operated is available inside a memory location, and that memory location is indirectly specified a register pair. For example, move A, M. It means move the content of the memory location pointed by the HL pair to the accumulator. And the last is implied or implicit addressing mode. In this mode, the operand is hidden and the data to be operated is available in the instruction itself. If address of source of data as well as address of destination of result is fixed, then there is no need to give any operator along with the instructions. So, for this addressing mode, the examples are CMA, that is complement accumulator, and the next one is RRC, that is rotate accumulator A right by 1 bit. And the next one is RLC, rotate accumulator A left by 1 bit. And now we are going to see how the data flow between memory and MPU, that is microprocessor unit. First of all, the 16-bit address is placed on the address bit from the program counter. Let's say the address is 2005H, where that is placed. The higher order address, that is 20H, is placed on the address bus A8 to A15, while the lower order address, that is 05H, is placed on the multiplexed address and data bus AD0 to AD7. The lower order address continue to remain on the address bus so long as ALE remains positive. What is ALE? ALE means address latch enable. Once ALE goes low, it carries data. The control unit sends the signal to indicate what type of operation is to be performed. Since the data is to be read from the memory, therefore, it sends to enable the memory chip. The byte from the memory location is then placed on the data bus, that is 4F saved in location 2005H is placed on the data bus and sent to the instruction decoder. The instruction is decoded and accordingly the task is performed by the ALU. What is ALU? Arithmetic and logic unit. Finally, the process is performed by ALU. These are the methods of how the data flow between memory and MPU. Thank you.